Good afternoon. A very warm welcome to all of you, and thank you for joining us today. On behalf of Digital Technologies Private Limited, I am delighted to welcome you to this live webinar titled From Code to Qubit, an easy start to quantum scale technology and computation. Quantum computing is often seen as a complex and highly theoretical field, but today's session is designed to simplify quantum computing, connect it with familiar programming concepts, and help you understand how to start your journey from classical code to quantum systems. This webinar is structured especially for students, educators, researchers, and engineers who want a clear and practical introduction without heavy mathematics. Let me start by briefing introducing digital technologies and what we stand for. So, Digital Technologies is a technology solution provider focused on supporting academia, industry, and research through advanced engineering solutions. This means we don't just sell products, we help institutions, researchers, and companies build complete engineering ecosystems that are practical, scalable, and industry aligned. So, our work spans three major pillars, that is, academia, where we support universities with lab setups, curriculum aligned experiments, and hands on learning platforms. Industry, where we enable product development, testing, and validation. And research, where we provide support, advanced experimentation, and innovation. So, core technology domains where we work on our embedded systems, embedded AI, edge intelligence, IIoT, AIoT, FPGA platforms, and test and measurement technologies. So, in addition, Digitode enables wireless RF and 5G or 6G research using dedicated tools and controlled lab environments. This includes support for advanced wireless testing, signal analysis, and next generation communication research, which are essential for future telecom and defense applications. One of Digitode's strongest capability is designing and deploying the complete lab setups. This includes hardware platform, software tools, structured experiments, faculty and student training. These labs are not theoretical, they are fully functional industry grade labs, many of which are showcased on our websites. At the core of everything we do is one clear goal, that is building industry ready engineering ecosystem. So talking about our key solutions, Digitote provides end-to-end automated test and measurement solutions. So these solutions focus on sensing, data acquisition, high performance real-time monitoring. They are used across industrial testing, research labs, academic environments, helping users move from manual testing to automated, repeatable, and accurate measurements. And in AI domain, Digitote focus on edge AI, AIoT, industrial IoT, as well as vision AI workflows. So these workflows enable real-time intelligence directly on embedded systems rather than relying on cloud computing. This is especially important for applications like predictive maintenance, smart sensing robotics. Just a minute. Yeah. Okay. So in AI domain, Digitote focus on edge AI, AIoT, industrial IoT, and vision AI workflows. So this is especially important for applications like predictive maintenance, smart sensing, robotics, and autonomous systems. And we also work extensively in FPGA and semiconductor technologies. So this includes design verifications and prototyping. These solutions support advanced computing and hardware acceleration, which are essential for AI, signal processing, and high speed systems. In the wireless domain, Digitode enables 5G and 6G research. This includes advanced wireless testing and prototyping. These solutions help institutions and organizations prepare for next generation communication technologies. Finally, Digitoad supports quantum and optical solutions. This includes high performance test and characterization systems for quantum communication, quantum computing, fiber optic networks, photonic devices. This is where today's webinar topic, quantum computing, fits naturally into today Digitoad's broader technology system. Moving on to the next slide. So on this slide, I wanted to highlight on our technology collaborations, which form the backbone of the solution we deliver at Digital. So we work closely with global technology leaders across embedded systems, wireless communication, measurement, and quantum computing and advanced networking. So these collaborations help us provide end-to-end lab solutions from fundamentals to advanced research use cases. Starting with ST Microelectronics, we leverage their microcontrollers, sensors, and AGI ecosystems to build strong foundations in embedded systems, IoT, AIoT, and industrial control applications. Through TMY Tech, we support advanced 5G, 6G, and mmWave technology, including beamforming, phased arrays, and wireless signal experimentation. Our collaboration with Digiland, now part of Emerson, allows us to offer powerful test and measurement platforms such as analog discovery and FPGA based learning systems. With qBraid, we address the rapidly growing domain of quantum computing education and research. qBraid provides a unified cloud based platform that supports multiple quantum frameworks and hardware backends, making it easier for students, faculties, and researchers to learn and experiment without complex setup. We also work with Mantis Wave Network to enable private 5G and edge networking solutions, which are critical for Industry 4.0, smart campus, and secure IoT deployments. Additionally, partnered with Emona, strengthen our offering in communication systems and signal processing educations, ensuring strong theoretical understanding combined with practical implementation. So now let's come to the key collaboration that directly relates to today's webinar. Digitoad and qBraid collaborate to bring structured quantum computing education to academia and research institutions. So this collaboration is designed to make quantum computing accessible, practical, and structured rather than abstract and intimidating. Through these collaborations, users get access to web-based quantum computing platform. This platform supports learning, development, and experimentation. You don't need a specialized local hardware to get started. Everything is accessible through a unified environment. So users can work with multiple quantum frameworks, simulators, and real quantum hardware. All of this is available through a single integrated platform, which is greatly simplifies the learning and research process. Together, Digitoad and qBraid supports teaching, academic labs, and research workflows. This includes guided content, structured tools, and platform access, making it suitable for both beginners and advanced users. Now, it gives me an sorry. Now it gives me a great pleasure to introduce our resource person for today's webinar. Mr. Harshit Gupta is a quantum software engineer and developer actively working in the quantum computing ecosystem. He has over 2 years of hands-on experience in building and enabling practical quantum software workflows. Harshit's core expertise lies in some of the most critical layers of quantum computing, including quantum compilation, and distributed systems. These areas form the backbone of real-world quantum software development. He have contributed to important quantum software projects such as PyQuasm, which helps bridge quantum assembly languages, qBraid SDK, enabling unified access to quantum tools and hardware, qBraid QIR, which supports intermediate representation for quantum programs. These projects play a key role in making quantum computing accessible, portable, and developer friendly. Before we begin the technical session, let me briefly outline what we will cover in today's webinar. First, we will look at the qBraid's First, we will look at the qBraid's approach to quantum computing. Next, we will understand the quantum computing workflow. We will then explore an overview of qBraid tools. Harshit will also discuss the quantum academic use cases. Another important focus will be ease of use and academic integration. So, overall, today's session is designed to be practical, beginner friendly, and application oriented. Now that we have set the content for today's webinar, it's time to move into the main session. So it's my immense pleasure to hand over the session to Mr. Harshit Gupta, who will take us through the quantum computing concepts, tools, and workflows in the webinar. Over to you, Harshit.
Thank you so much, Govardhani. That was an amazing context building. Hi, everyone. Thank you to you all for joining in and giving your precious time to this webinar. My name is Harshit, and today we're going to be talking about quantum computing. It's a very new topic. It's very exciting, and I'm really excited to present this to you guys. So before I get started, let me just confirm some logistical things. Govardhani, is my screen visible to you?
Yes, Harshit.
Okay, perfect. And my voice is coming
Yes, everything
clearly?
is clear.
All right, perfect. Okay, so what exactly is qBraid? qBraid is a one-stop platform for quantum computing, wherein we provide access to different quantum systems and environments right there in the cloud. I work there as an engineer and have been working there for, I would say, around 2 years or so. And today I'm going to be presenting our platform, our features, and how our platform is going to be useful to you guys inside academia, whether it is industry or whether you're just, an inquisitive person who wants to know more about quantum. qBraid is built for all of you. So the agenda is not very big. We're going to be talking about an overview of our platform, um, the flagship product of qBraid, that's qBraid Lab, our education initiative, which is called the QBook and the QBook Builder. And then we'll have some live demos and time for questions as well. So we have built our platform to be as comprehensive as possible and to reduce the inertia of getting into a complex field like quantum computing. We provide access to quantum systems right there in the cloud and also a custom environments for you to use those systems. Not only that, we also have a domain of quantum education in which we have worked on for, I would say, three or more than 3 years. And we provide quantum education and courses directly in the cloud. We're a premier quantum dedicated platform for your university, and we provide access to more than 25 plus quantum devices right there in the cloud, enabling you and your organizations to distribute these features to your users, and not only that but also teach and deploy courses with our in-house features such as qbook. We provide seamless access to quantum processing units so that you don't have to manage or you don't have to tune your own environments to access different vendors such as, let's say, IBM, IQM, or Rigetti. You can basically consult with our team to make sure that any course that you're trying to run or any kind of upskilling initiative which you're trying to onboard inside your company has the appropriate hardware access. You can essentially manage each and every seat or the user access for a specific hardware using qBraid, and we can provide different levels of granularity for that access. Not only that, we also provide credits for users to run actual quantum jobs on different quantum systems. And this is a testament to our current features. We have 24,000 plus users on qBraid who actively use quantum devices and run quantum jobs. We have 30 plus quantum software environments which are available through qBraid Lab, 24 plus quantum devices, and an array of university licenses which are currently running quantum computing courses in the United States. Now, I'd like to take a step back and actually describe what a quantum program actually looks like and what the quantum computing workflow looks like, right? So, this is about the life cycle of executing any quantum program on a quantum device using qBraid. So, first of all, we of course have to log into our qBraid lab, which is the online coding environment that we provide. I'm sorry. Once you're on qBraid Lab, you write your quantum program using the qBraid SDK, which is a Python package. Internal to qBraid SDK are some transformations which enable your program to run on a specific device. We pass on that program to our backend APIs, which interact with the quantum systems and get you back the results, which is part of the qBraid runtime. So this is the execution flow of a particular quantum program. Now, let's dissect each component, which I talked about right now. qBraid Lab. So I think most of you are very familiar with the Jupyter notebook-based environments, right? So qBraid Lab is a cloud-based IDE, which allows you to seamlessly code for quantum computers. And not only that, but also collaborate. So qBraid Lab is available on lab.qbraid.com, and you can just skip the hassle of cloud and authentication setup for different quantum computing providers and the hassle of management, of different dependencies whenever you're trying to run some kind of a program with, let's say, Qiskit or Cirq or any kind of quantum computing packages which is available right now. We also have pre-configured access to different quantum algorithm tutorials, documentations, and also AI copilots built in so that you can immediately start up with your quantum computing workflows. Next, we come to the qBraid SDK. This is what enables you to do something on qBraid Labs. So qBraid SDK is our flagship toolkit, which we have built to bridge your code to any quantum backend. We allow users to code in any framework that they like, whether it be Qiskit, Cirq, PyQuil, and I would say QIR or Bracket, right? You could code in any framework and you can connect with any particular quantum backend, given that it is supported by our platform, with a single unified API key, which is called the qBraid API key. You don't have to worry about tough transpilations or transpilation between different frameworks, such as quantum assembly language or quantum intermediate representation. We do that for you in the backend, where you just need to worry about what you want to do, and we will figure out how you're going to be doing it through qBraid SDK. Now that's a lot of talk. Let's actually go into a demo. Okay, so this is qBraid.com, and this is our landing page whenever you search for qBraid. Now, obviously, you need an account to do anything on any platform, right? So we click on login, and it's going to be opening up an account dashboard for you, right? So what does it mean? This specifies what kind of a plan you have for qBraid. So for example, I have the standard plan. What are your authentication credentials, such as your API key? What are your credits or the quantum credits, which are used to submit quantum jobs and run GPU instances on qBraid? And a lot more information, which I will go on in a moment. Here, I will highlight a couple of features, that is devices and quantum jobs. So what do I mean by devices? So I told that we have integrations with different devices, right? All of those devices are present here. Let's take an example. We provide access to the IQM's Emerald device as well, right? And this basically represents what kind of information is present for that device, such as what kind of a device it is. It is an actual QPU. What access do we have? So, for example, it uses Bracket. What is the pricing of the device? So, for example, it has 30 credits per task and 0.16 credits per shot. And what are the number of qubits, right? Not only this, we also have different devices from different quantum computing vendors, right? This is about the devices tab. And then we go on to the quantum jobs tab. This is essentially a console which allows you to manage different quantum computing jobs, which you are submitting through qBraid, right? So let's take an example of a device which I just submitted like 2 hours ago, the IQM job. So I submitted on IQM Emerald, right? And it was created like a couple of hours ago. This was the number of shots, this was the cost, and this was the qubit count, right? So overall, this is basically two of our flagship features which we provide over qBraid: devices which you can access and jobs which you can run, right? Okay, perfect. Now let's run some jobs, right? This is our, lab launcher. And what this does is that it basically provides you an ability to launch Jupyter Notebook instances right there in your cloud. So I already have an instance running for the purposes of this demo. So I will just go there, right? And this is what you'll see whenever you launch lab. You have those extensions available here as well on the right side, the devices and the jobs, right? And then you have your code here, right? And on the left, you have files. So this is basically the vanilla Jupyter Notebook interface, which most of you would be familiar with, definitely. Then we start running our code. And before we do that, we need to understand what it is actually doing, right? So I talked about the execution model for quantum, right? That we're going to be going on to lab. We write a quantum program, we let it go through Qubit SDK and get back some results. Let's do that. So what I'm doing is importing qBraid, getting the devices which are available. So for the purposes of this demo, we're going to target AWS SV1 simulator, and let's get that device. And for those of you who are not familiar with the Bell state, this is basically the hello world of quantum computing. So I'm sure a lot of you have coded hello world in C, right? Where you say print F hello world, right? This is kind of analogous to that. And we're just using two qubits to execute a quantum circuit on a quantum device. That's it. So we will code in two particular packages. One is Circ, which is the quantum computing package of Google, and Qiskit, which is the quantum computing package of IBM. The beauty about Qubit SDK is that you can code in any of these two packages and still execute on AWS devices which accept Bracket, right? So let me do that. So this is our circuit. This is a very small circuit. Let me zoom in a little bit. And then I ran this a while ago, but I'll run it again. You can see the job is queued here, right? And will execute in a while. We can do similar things with Qiskit as well. So we build a circuit in Qiskit and we execute it on AWS simulators, right? Of course, it'll take some time for the job queuing, right? But I will move forward and I'll let that job execute. This is a very similar circuit in which we execute Qiskit circuit on an AWS device, right? And so we have the results now. And you can see that the job was executed here. So this one is completed, and these are the details. It costs us like 0.38 credits, which is not much. And then we also have similar execution flow for the Qiskit circuit, right? But we can also do this for an actual device. So we have different quantum computing devices available. So for example, the Anka 3 device, which is provided by Rigetti. So it has 82 qubits, and this is the pricing for this particular device. The workflow is very similar. You get your device, you basically run your circuit on your device, and just get your result. It's as simple as that. It is, I would say, if we count, it's going to be less than 10 lines of code for doing that, right? And we also have results for the Qiskit job. Now, one thing to note is that the actual jobs cost real money, right? So I'm not going to be executing the real jobs again. I just executed like a couple of hours ago, and these were the results. These were very similar to the results which we achieved here, which is 0, 0 and 1, 1 were the only counts which we got. But since this is an actual quantum device, those devices are also characterized by something called quantum noise. So that is why you see, counts from 0, 1 and 1, 0 states as well. But all in all, these the execution result is as expected, and that is the majority of the counts are in either 0 0 or 1 1 state, right? So this was essentially about explaining this whole workflow and bringing together what qBraid Lab and qBraid SDK mean in a context when you're executing real programs, right? Okay, perfect. Let me close this. But this is just one aspect of qBraid, right? We also work very closely with the quantum education domain, and we aim to simplify it. We have an interactive and a very flexible quantum education platform, which is called QBook. It allows both students as well as enterprise customers to deploy courses, generate certificates, and train their workforce. So you could potentially be, let's say a researcher or a professor who's trying to run a course inside your university. You could use QBook to deploy your course, allow your students to onboard it, run that course, and give out certificates or grade them, right? You could set up quantum computing infrastructure directly on the cloud using QBook, and that is its beauty, right? We do not want very heavy setup instructions whenever we're trying to achieve something, right? We want it to be as seamless as possible. That is why a minimal setup is needed to onboard users for their courses and distribute qBraid credits to them. Users can log in for qBraid Lab for running experiments, and they can complete courses on QBook, right? So those are two different things. qBraid Lab is for running experiments, QBook is for courses. And not only that, instructors or TAs can use those admin features which are present in QBook already for grading and management of users during this whole curriculum. And again, let's have a demo, right? Let's see some moving pieces because that's how at least I understand the best. All right, so let's go to qbook.com. And this is already live and I'm logged in as my account, right? We have different courses available for different people. And let me go through the beginner course so that a lot of you can understand the best, right? So let's take a moment to digest all of this. On the left, you see the sections or the chapters of this particular course, right? So, for example, since this is the introduction to quantum computing course, we obviously have an introduction. We have quantum mechanics, an intro to that. We have classical computing, background math, and each and every chapter has different subsections, right? So, this is about this part of the course. Now, the center is basically the content of the course or whatever content is present for your particular student, right? And I'd like to highlight all its features. It's not only text oriented, but a lot more than that. We have interactive widgets which you can play around with or embed, right? And the most important feature, which we're very proud of, is embedded code snippets right there in the browser, right? So if I click on play, this will render the code directly in your browser and allow your students to, play and learn with your code rather than just digesting the textual information. Not only this, we also have features to embed YouTube videos, such as for lectures, right? And this could be customized according to whatever you need, right? Besides that, we also have quizzes and and answers which students can submit and be graded upon automatically in our backend, right? So, for example, there's an MCQ question. Then this is, I would say, let's say 5 and whatever 135 degrees, right? Something like that. And then this would be submitted, and the grader or the instructor is going to be grading this on the back end for your courses, right? So this is very important in the sense that it's not only a passive learning platform, but an active learning platform where students interact with your course, submit quizzes, submit assignments, run code, and have, I would say, a very rich learning experience rather than a very passive learning experience, right? Now, this is about the students, right? How do professors or research assistants or TAs manage all of this, right? We have thought of all of that, and how you do that is through organizations. Okay. So what do I mean by organization? Again, let's take an example. So for the purposes of this demo, I've made a test organization called Digital qBraid Test, right? It has me as an owner, Govardhani, our amazing presenter, as an admin, and my other account as a user, right? So if you are a professor in a university and you want to, onboard a course, how you do that is that we create an organization for you, and then we attach a course to that organization, right? Now, if you want to onboard, let's say, any user, you just provide their email here, right? And this could be provided through Sheets as well or a CSV format, and invite them, right? Once they're part of this course, you could distribute credits to that particular user. But not only that, also edit those users, right? So these seats are not fixed. So, for example, if this particular user is part of the course for one particular semester, it doesn't have to be that they have to be part of it the next semester as well. You could offload that student and onboard a new session of students during the next curriculum session, right? So that is, I would say, a very important feature for the course management of qBraid as well. Besides this, we also have an admin panel, which is important for the grading of these courses. And if any one of you are interested, I'd be love to, give you a separate demo for that. But for the purposes of time, I think I would probably not go into much detail for that. And yeah, I think we are kind of before time. So I would love to open the floor for questions. And if you guys have, any specific questions, any doubts, I'm right here and you can ask that. And this is our contact information if you guys want. I could also share the slides as well with you. Govardhani, we can do that, I think, after the webinar. And yeah, thanks a lot, guys. Thank you.
Hello all. If you have any questions during the session, please feel to free to drop them in the chat box. So Harshit will solve the queries.
Oh, I'm sorry, I didn't see that my voice is echoing, Bhavna. I'm just
No,
seeing that right
actually it
now.
was okay only. I
Oh, okay.
think like they have joined with the two devices.
Okay. Hi, Mahendra. Nice to meet you. So yeah, definitely we can have an MOU in this regards. Can you reach out to Govardhani about what are your exact requirements, and then maybe we could go through that route, because how we're planning this is that uh, qBraid and Digitoad are acting as partners, and any collaboration which is going through academia, I think, is going through Digitoad technologies, right? So I think it'll be best if you contact Govardhani, and then he can share the requirements with me. Vishali. Hi, Vishali. Internship opportunities in quantum computing. Definitely summer internship opportunities. For winter internship, I'm not really sure for qBraid, but there is a program that you should check out that's called the QOSF program, which takes in mentees on a rolling basis. So you should definitely check that out. Contact details of him. Who? Of me? I'm not sure. I mean, I can reach out to you. Answer or share. qBraid.com. Sumit is asking, how will this help in research point of view? Yeah, great question, Sumit. So I showed you, right, that we have qBraid credits available for accessing different quantum devices, right? So if you have a requirement in your research which needs access to different quantum systems, we can do that for you. So we can provide you, let's say, qBraid credits, which you can then use to actually submit quantum jobs on different devices, and then maybe help in your research if it is using uh, different quantum devices. So yeah, it's, How to start a career in quantum computing? Amazing question. Even I don't have a very clear answer for that. I would say that it all depends on your interest because quantum computing is a very wide field and it doesn't necessarily have to be a research oriented career. Even people from marketing and sales are very, very important in a field like quantum computing because people are trying to understand how these systems and how these workflows, relate with their day-to-day technologies, right? And their day-to-day business. So I would say it all depends on your interest. If you're interested in software development, then open source technologies are the best way to get started because open source invites a lot of users to submit PRs or submit contributions to different projects. And I think that is how you get the feel of what it means to work in quantum software. Besides that, for hardware, I would definitely recommend going into a graduate program because hardware is something which is not very easily picked up by studying on your own. You kind of need a mentor or some formal training to actually go into the hardware type of field. So yeah, repeat the program. Yeah, so it's called QOSF. I'll type that as well. QOSF mentorship program. Hi, Suman. So his question is about running a QML task with 30 features. Um, I I'm not really aware of running QML tasks, Soman, because that's not my area of expertise. But I think if you're suffering from a memory overflow, it's most likely that you're trying to simulate it on a quantum simulator. Most likely, you'll need to execute on a real device for executing that. I think kernel. So, but yeah, I would recommend executing on a real device. Then I think Penny Lane has some amazing tutorials for quantum machine learning. Um, okay, quantum hardware available with the organization. Hi, Vishali. So Vishali is asking, is quantum hardware available with organizations? Yes. So whenever you're part of an organization, right, you're going to be provided some number of credits, right? So those credits can be availed to run quantum jobs on any quantum hardware. So by default, every quantum system present on qBraid is accessible to everybody. The only way to access them is through qBraid credits. So whether you're part of an organization or not, you're by default going to be having the access to all devices, right? But you will need to buy qBraid credits or be provided that through your organization so that you can use them. Yes. Sandhyarini is asking, how does it work in respect to a diagnostic laboratory? What is the utility? Could you clarify a little bit on that, Sandhyarini? So Momita is asking about how do we use quantum hardware? Is it through qBraid credits? Yes, that's correct. You basically use qBraid credits to run quantum jobs on different devices. And whenever you wanna, run quantum jobs, you need to buy some kind of qBraid credits to run them. But if you're actually part of a university course, right, we will be providing qBraid credits to your university and then they will be distributing to you so that you can access those devices. So yeah, is IBM charging hourly basics to use quantum platform only for simulation? I'm not sure about what you mean by hourly basics, Krishna. How to get qubit credits? Yeah, so let me again start sharing my screen and answer that question. I don't think I showed how you could actually buy credits. Yeah, so you go to your account, right? When you have logged in, you go to credits and then you go to buy credits, right? Obviously, you'll not need so many credits. So for starters, we recommend like 1,000 credits or like 2,500 credits to just get started, and that should get you a feel of the platform, right? And once you do that, if you like the platform, I hope you do, then you can buy more credits, or you could reach out to us, and then if you are buying credits in bulk, then maybe we can provide you with some discounts. We definitely do provide discounts for academic use cases. So yeah. All right. That should be answered. All right. What is the use of quantum computing in diagnostic lab? Okay, so Sandhyani is asking, what's the use of quantum computing in diagnostic laboratory in hospitals? All right. So not a lot of use in diagnostic laboratories per se, but there's definitely some use cases which are present in, I think, computer vision and disease detection. I think so because, yeah, to be fair, I'm not very familiar with the field of quantum machine learning, right? But definitely quantum systems are being used to, one in quantum machine learning, but also second, in quantum simulation or quantum drug simulation, right? So there are some molecules which are actually interactable to simulate on a classical device, and people are doing active research for simulating those vaccines or drugs on quantum computers. So yeah, I'm not sure if it is directly usable in a diagnostic laboratory, but yeah, I do know some use cases in medicine at least. Academician benefits applicable. What do you mean by maximum data handling capacity? What kind of data? Is it like student data or like quantum job data, program data? What do you mean by that? Gaurav? ML datasets. Okay, so yeah, good question. So by default, we provide 15 gigabytes of storage. I think, is it 15? I think it's 5 or 15. So by default, we provide 5 or 15 gigabytes of storage for your lab instance and around 2 gigs of RAM. But if you want to upgrade your plan, then you need to buy like a standard or a pro subscription to qBraid, and then you will be provided with a larger RAM instance. But also, we also have GPUs available, right? So let me share the screen again and let you know. Okay. So we also have GPUs available in qBraid, and we have like different NVIDIA GPUs available through qBraid. But these do, cost you to run your instance. So, for example, we have H100s, A100s, right? And if you launch lab, it will take like 10 or 15 minutes to spawn that GPU up. It is slow, I agree, but we're constantly working on it. But you can definitely use these GPU instances as well for your, larger ML use cases directly on qBraid. Do you have any idea about quantum communication, which is said to be 7G? No, I'm not aware of what 7G means in terms of quantum communication. I'm sorry. Um, Besides that, yeah, I don't see a lot of questions now, Govardhani.
Yes, Harshit, we'll wait for 2 more minutes.
Can we get an opportunity for hands-on? Yeah, definitely, Gaurav. So you can just, log into qBraid and just start your hands-on journey there. So basically, you log into your qBraid account, you launch a qBraid instance, right? And then you're just good to go. Govardhani, can we share some documentation and links to qBraid docs to the panel to the attendees, right? Because I'm not sure if I can see a chat here where I can send those to them, because that would solve a lot of questions from the attendees.
Sure, Harshit. Like we can share the PPT which we have presented.
Yep, yep, sure. Guide how to use quantum computing in telecommunication domain. It would definitely. So one person is asking, how do we use quantum computing in telecommunication domain? It would definitely depend on what you're trying to achieve, because quantum computing is providing a particular speed up in very specific problems or very specific research problems, right? So if you have some kinds of problems which require very, large simulation time or large amount of simulation resources, right? Then definitely quantum could help. But I think quantum networking is what would probably be more helpful in the telecommunication domain, because quantum computing is about, using quantum resources to solve resource intensive problems, right? So I would recommend looking into quantum networking rather than quantum computing.
Just a minute. Like Venkat Ganesh have raised the hand. So you can drop your question on the chat box. So Harshit will address it.
Could you please tell the need for quantum over classical through quantum mechanics advantage? Right. So I could give a brief overview. So basically, there are some problems which scale exponentially in the terms of compute resources. So, what do I mean by that? So, for example, if you have a problem which scales, let's say, whenever you add one more variable, it doubles in size, right? Something like that. So, that is what I mean by exponential scaling. That could be actually achieved through a linear number of qubits in some particular problems, right? So if you have an algorithmic complexity of big O of 2 raised to n in terms of the memory required, right? That could be scaled down to big O of n in terms of the number of qubits required to simulate that problem, given you have perfect logical qubits, right? We don't have them right now. But if we do, the scaling then basically reduces from O2 to the n to O order of n, right? And how do we do that? There are three important properties of quantum mechanics which is used in quantum. That is called quantum interference, quantum superposition, and entanglement, right? So these three properties together, they form the backbone of quantum computing. And I could go on in more detail, but it would require, I think, one more lecture or two more lectures of why, of how that mathematics works. But that is like this short answer. Can we use quantum computing for predictive analyses? What do you mean by ECG analysis? Like the heart rate analysis? I think so. You're welcome, Saman. Okay. Yeah. So I think, again, that is diving into the domain of QML, which I'm not very familiar with. But definitely, if you have a quantum machine learning model in which you can embed your ECG data as part of a quantum circuit, then train a quantum ansatz model. So a QML model is called an so a quantum circuit which is trained to be a ML model is called an ansatz. If you can train the right ansatz circuit with your right ECG data, definitely you can use it for predictive analysis. But personally, I'm not very familiar with that QML domain, so I would again guide you to the better resource that would be Penny Lane. So Penny Lane has some amazing QML resources. You should definitely look into them. Penny Lane. Uh, okay. How orbital angular momentum is related to quantum communication? I'm personally not aware of that, so I'll not be able to answer that question. So apologies. All right, I think I don't see more questions coming up. Govind, let's wait for a couple more minutes and then maybe we can end early and give some time back to our participants.
Yeah, sure.
Okay.
We'll try to end the session at 3:55, so it will be okay, I
Yep,
guess.
some suggested books. Yeah, definitely. So Mike and Ike. So Michael Nielsen and Isaac Chuang is a book which I personally refer to. Michael Nielsen and Isaac Chuang. Then there's also the theoretical minimum from Leonard Susskind that has amazing quantum mechanics overviews. And I think if you're looking for some more theory, I think um, Lectures of Physics by Feynman should also be very good lectures. But I'm not sure which volume has quantum mechanics, so just confirm. Yep. But yeah, personally, I would say if you're looking for a very practical introduction, diving into open source technologies is one of the best ways to learn by doing, basically. So yeah, I would definitely recommend to that. What kind of research work can we do this with? It's a project work. Okay, so Bhavna is asking what kind of research work can be given to students as their projects. That's a great question. So that would depend on the type of course that you're running. So for example, if you're running, let's say, the beginner, the introduction to quantum computing course, right? And people are not very familiar with quantum computers to start with, right? So I would recommend giving something like a project such as building a library of algorithms so that people can get acquainted with algorithms inside in different types of quantum settings, right? Or you could have projects such as taking an algorithm, then benchmarking it across different systems which are available on qBraid, right? Because right now what's happening is that there are a lot of devices present in the current quantum computing landscape, and people are not sure which particular device to use, so they tend to be confused. So if we have some kind of good benchmarks to evaluate which device to use in which particular problem, that could be a pretty great project. And then I can write this down. That will be better. Okay, so I gave like three topics, Bhavna. How does quantum computing? What do you mean by MD simulations? I'm not sure what the name of that ND is. Like they're asking how does quantum computing help in MD simulations? What is MD? Hmm. Okay. You're welcome, Bhavna. Yep. You can again direct any queries that you have to contact at qbraid.com or reach out to Govardhani, reach out to me. We're more than happy to help. You're welcome. All right. I think it was great talking to you, everybody, and looking forward to what you all do on qBraid. And if you have any questions, any doubts, just feel free to reach out to us. We're always available. And thanks again for organizing this webinar, Govardhani. And yeah, looking forward to our collaboration.
So thank you, Harshit, for the great webinar session.